Hello and welcome to Triangle Midsegments. As a reminder, a midsegment is a line, in this case within a triangle, that connects the midpoints of any two sides of that triangle. So what we're talking about here is we're going to draw a little triangle. We're going to label it triangle A, B, C. And the midpoint, we'll call the midpoint D, E, is the line that connects any two sides. So what that means is that it's going to connect it right in half. So it's going to make DB equal to DA and BE equal to EC. Now that's not the only midsegment that I have available. I could also have a point F down here, which would cut AC in half. And I could have midsegment DF or midsegment EF. So what that's going to do is say that I have midsegment DE, DF, and EF are all midsegments. Now, one of the really nice things is back when we were doing trapezoids, we talked about how a midsegment was the average length between the top and the bottom. Well, in a triangle, there is no top because it comes up to a point. So the length of the midsegment is exactly half of the length of the side of the triangle that it is parallel to. So what that means is that DE is exactly half of the whole AC. Now I know a lot of you don't like fractions, so what we could do is we could multiply both sides by 2 and get that 2 times DE equals AC. Alright, so let's go ahead and see how we can use this formula. Let's go ahead and look at our first example. They want us to find x. Now if we look at triangle ABC, we notice that we're going to label these points so we know how to talk about them. We're going to label that D and E. AD is the same as BD, and AE is the same as EC. That means that X, that line DE, is going to be the midsegment, which means we can use our formula. So I'm going to write 2 times length DE equals BC, the line that it's parallel to. So if I look at this, I'm going to fill in all my appropriate information. So 2 times DE is X equals BC is 30. And then I just have to solve for X. So that means I'm going to divide both sides by 2 and get X is 15. That's not too bad. Now the next thing says find the perimeter of triangle ABC. Now to find a perimeter, that means I need to add up how long the outside is. So let's start up here in the top. So AD is 9 plus, oh no, they didn't tell us how long DB is, but they did tell us it's the same length as AD. We know that AD is 9, which means that DB is also 9. So 9 plus 9 plus 30 for BC plus 10 for EC plus, oh no, again, they didn't tell us how long EA is, but they did tell us it's the same length as EC. Since EC is 10, that means that AE has to be 10, so plus 10. So I have 18 plus 30 plus 20, which is going to give me 68. So the perimeter is 68. Now, let's go ahead and look at the second triangle, triangle DEF. They want us to find X. Now, as a reminder from our last slide, if we look at this length again, let's call it AB, length AB. Notice that it's cut in half on the bottom and it's cut in half on the side here. That means that that's a midsegment. Since that's a midsegment, these two are parallel lines. Since they're parallel lines, that means that X and 50 degrees are special angles. Anybody remember what those special angles are called? I'll give you a second to think about it. You're right, they're corresponding angles. And what do we know about corresponding angles? They are congruent. That means that X is 50 degrees. Not too shabby. Y is a little bit more difficult to solve for, but not really. They're just trying to trick you. If I look at big triangle DEF, that is a triangle. We know that all triangles add up to 180 degrees. So 180 equals 50 plus 60 plus y. And then I just have to solve for y. So 180 equals 110 plus y. Subtract 110 on both sides. And I get 70 degrees equals y. All right, we're rocking this out. Let's go to our next set of questions. We're going to get a little bit more complicated. Now, they say in triangle RST, the midpoints of each side have been marked by x, y, and z. They already did that for us. We want to mark the halves of each side by the midpoint with a congruency mark. What that means is they want us to make hashtags here, some more hashtags over here, and a third set of hashtags down here. That just shows that the sides are the same. Then they want us to draw a midsegment XY, okay, YZ, okay, and XZ. Not too bad. Mark each midsegment with the appropriate congruency mark from the sides of the triangle. So what that means is that these sides of this triangle in the middle have to be marked with the same congruency as the other sides that we've already labeled. Now how do we figure that out? We can look and see what's parallel. So if I look at ST, so ST is going to be parallel to XY. That means that SZ is the same as XY, so that length is the same. We also know that YZ, since that's a midsegment, is going to be parallel to RS. Since that's parallel and this is half of those segments, that one gets the 1 dash mark. Finally, XZ is parallel to RT. And remember, this is going to be half here, so this one gets 2 tick marks. So they want to say, what conclusion can we draw about the 4 triangles within RST? So if we look at all these triangles, look, I have a side, a side, a side, 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 side. Anybody can guess what we know about these triangles? They are the same. I bet you can tell me why. If we explain why, we should get side, side, side. So if we want to state the appropriate correspondence among the triangles for RST, let's start with the top one. So we're going to go R, so triangle R, Y, X. That's going to be congruent to triangle, remember we go 1, 2, 3. So if we go down here, let's start with Z. So Z, Y, T. Because we go 1, 2, 3. Again, if I want to go 1, 2, 3, so I'll go the middle one. 1, 2, 3. So that's congruent to triangle YZX for the 1, 2, 3. Whoops. Accidentally erased. So YZX, and we've got one more triangle. So 1, 2, 3 is SXZ. All right, that's not too bad. If we want to state a correspondence between RST and any one of the 4 smaller triangles, well, how many small triangles fit into the big triangle? Let's count them. We've got 1, 2, 3, and 4. So triangle RST is 4 of any one of the small triangles. So I'm just going to say triangle RYX, because we know from the second step above that all those triangles are the same. It's not too bad. Let's go to the next slide. All right, we're going to get a little more complicated in here. We want to find X. Now, if we want to find X, we know that this is 61 degrees, this is 40 degrees, this is X. So let's go back and we'll look at our previous slide. We'll look at what was equal. So if I look at this triangle, this angle should go with either this angle up here or this angle up here on this triangle. So those are all the same. If I want to look at the 40 degrees is equal to this angle inside this triangle or this angle inside this triangle. And the last one I want to look at is the 61 degrees. 61 degrees is here. We know because of triangle congruencies that is equal to this angle up here or this angle up here. So what I could do is just use any one of those triangles. I'm going to use the middle one because it's got X. And remember, all three angles of a triangle add up to 180 degrees. So 180 degrees equals x. Solving for that one. The red one we know is 61 degrees, so plus 61, plus the blue one we know is equal to 40 degrees, so 40. So 180 equals x plus 101. If I subtract 101 from each side, I'm going to get 79 degrees equals x. All right, let's get into some more complicated stuff here. Okay, we're going to use our knowledge of triangle congruence criteria to write proofs for the following problems. These are going to be pretty informal proofs because we just want to talk about what it is that we know. We have that WX is the midsegment of triangle ABC. That's pretty important. So we're going to highlight that. WX is the midsegment of ABC. And we have that YZ is the midsegment of CWX. A third important thing is that BX equals AW. So remember, if BX equals AW, get the highlighter thing, there we go. That means that those two sides are the same. So we're going to go mark that with a tick mark. That's really good information because when they cut them in half from our midsegments, remember if WX is the midsegment, that means that this guy is the same as BX. And it also means that WC is also the same as AW. But since those are the same, that means that these are also the same. So that means that BC equals AC. So if I've got two sides of a triangle that are the same, what kind of triangle is that? Well, that's an isosceles triangle. In an isosceles triangle, two sides of the triangle are the same and two angles are the same. Now what angles of that triangle are the same? They're the base angles. In this case, it's angle A and angle B. So angle A is congruent to angle B. Not too shabby. I'm going to let you guys write out the formal why. So I expect to see that. So I'm going to leave you space to write that. So for part B, it says, what is the relationship between YZ and AB? So if I go back and look at that, so we're going to say it says that WX is the midsegment of triangle ABC. So we're going to use some of our formulas that we were using very back on the first slide. So if WX is the midsegment of AB, we can use our formula. So 2WX equals AB. And it also says that YZ is a midsegment of CWX. So that means 2YZ equals WX. Okay, so now I've got two equations, but I need to somehow get YZ stuff equal to AB stuff. Well, I've got a WX in both sides, but one has 2WX and one has 1WX. And again, since I don't like fractions, I'm going to multiply everything on the right equation by 2, which is going to be 4YZ equals 2WX. Since these are now the same, I can substitute. So I can say that AB equals 4YZ, or I could say that YZ is 1/4 the length of AB. Again, not too bad. So we're going to allow you to tell me the y. So y here and y here. And that's all in my explanation of how I'm talking. I'm not going to write that down to make sure that you guys are paying attention. One more slide and then we're almost done, guys. Alright, this last one is a doozy. They give us a lot of information here. So let's try and break it down. First of all, I'm going to use my highlighter. So I know that AB is parallel to CD and AD is parallel to BC. Okay, so I'm going to highlight those. Those are parallel and those are parallel. Okay. It says that W, X, Y, and Z are midpoints. So I'm going to use a different color here. So midpoints tell me that AD, so this guy is equal to this guy. this guy over here is equal to this guy down here is equal to this guy, and this guy down here is equal to this guy down here. But because I have the other information back here that they were parallel, that means that I have a parallelogram, which means I don't need all these fancy tick marks. So let's get rid of some of those. Put my parallel sign back there. What that means is, since these are parallel to each other and I've got a parallelogram, that BY is actually the same as AW and YC is actually the same as WD. Similarly across, DZ is equal to AX and ZC is equal to BW. That's going to help us later on. They also give us a bunch of information that they already went ahead and labeled in our picture for us, so I'm not going to repeat all of that now. Let's go ahead and start by part A. They say they want us to find the measure of DZW. Well, first we got to find DZW. So let's see, DZW is right here, so we want this angle right here. In order to find DZW, it would be really nice if we could use some of the information we already learned today, which is the midsegments of a triangle. So let's see if I can find a triangle. Alright, so if I look at DWZ, well, that doesn't really help me. Let's go bigger. Let's go DAC. Okay, that means that WZ might be a midsegment of that triangle. Let's check. Is DA cut in half by W? Okay, it is. And is DC cut in half by Z? It also is. That's really nice. Since those are cut in half, that means that angle DZW and angle DCA are, you got it, corresponding angles. Corresponding angles are congruent, which means that DZW is 74 degrees. Now let's go on to part B. Part B says find the perimeter of ABYW. So let's figure that out. I'm going to highlight this in purple. A, B, Y, W. So this guy here. Alright. So if I look at that guy, I know that AW is half of AD. So AW is going to be 9, which means that BY is also going to be 9. And then this guy, they gave us XB. XB is half of the whole length. So this whole length here is going to be 10. And since that one's 10, so is the length over for WY. So I have 9 plus 9 plus 10 plus 10, which is going to give me 38. So the perimeter of ABYW is 38. Now if I look at ABCD, ABCD is the entire shape. Well, I can already use some of the information I have. I know that AD is 18. So if AD is 18, so is BC. And then I learned from part B that AB was 10. And since AB is 10, so is DC because it's a parallelogram. So that gives us 36 plus 20, which is going to be 56. So the perimeter of ABCD is going to be 56. Alright, we're doing alright so far. Now, let's look at measure of angle WAX. So let's see, WAX is this whole big angle right here. They want the big guy. Well, we know this part is 33. They already gave us that. That was kind of nice. And we got to figure out this little piece right here. Now, as a reminder, this is a parallelogram. So one of the issues we have with parallelograms is that opposite angles are equal. So that means that this guy right here, angle RAX, is going to be an alternate interior angle to angle DCR. So that means that this little guy in here is 74 degrees. So in order to find WAX, all I got to do is take 33 plus 74, which is going to give me 107 degrees. Alright, let's continue on. If I want to find the measure of angle B, well, I bet you guys can find the measure of angle B without doing any work. If you guess 73, you're right. They gave us that one. Next, let's find YCZ. So YCZ, again, we already found that one. We just haven't labeled the other side because again we have alternate interior angles with WAR and RCY. Those are alternate interior angles because we have a pair of parallel lines. So that's 33. So if I want to find the whole thing, which was YZW, I have 74 plus 33, which again is 107 degrees. Lastly, they want us to find the measure of angle D. If we look at the measure of angle D, again, I've got opposite sides of opposite angles of parallelogram are congruent, so that should just be 73. And if you guys haven't guessed it by now, what kind of quadrilateral is ABCD? It is a parallelogram. I would really hope by now everybody figured that out because we'd had two sets of parallel sides. Alright, that's all for today. Happy hunting, and if you want to get started early on your IXL, we're going to do IXL M1.